three-point starter. A three-point starter with its electrical connections and protective features is illustrated on the screen. Construction-wise, a starter is a variable resistance integrated into a number of sections as shown on the screen. The contact points of these sections are called studs and are shown separately as off, 1, 2, 3, 4, 5, run. Other than that, there are three main points referred to as 1. L-line terminal connected to positive of supply. 2. A armature terminal connected to the armature winding. 3. F field terminal connected to the field winding. Since only three terminals L, A, F are available from the starter, it is called a three-point starter. Case 1. Motor is in off rest position. When the motor is at rest, starter handle H is kept in the off position by a strong spiral spring. The stud off, as shown in the figure, indicates that the motor is disconnected from the supply. Case 2. Motor starting. As highlighted on the screen, the starting resistance is connected between contact studs 1, 2, 3, 4, 5. For starting the motor, the handle is rotated to come in contact with stud 1. As soon as handle H touches stud 1, the shunt field and holding coil HC gets connected in series across the supply, whereas the armature gets connected in series with the entire starting resistance. Since the current begins to flow in both the field and armature windings, the motor starts rotating. After the motor has picked up sufficient speed, the handle H is moved to stud 2, thereby cutting out the resistance between studs 1 and 2. Movement of the handle is continued slowly till the soft iron keeper touches the holding magnet HC. Note, at this point, the field current IF reduces from its rated value. So, if the field current reduces, it affects the flux. Thereby, speed increases as given by the following relation. During the waiting period on each stud, the armature current falls and speed rises exponentially as shown in the graph. The fall of armature current per unit is shown on the screen in the waiting period. The exponential rise of speed with respect to time is shown on the screen. The field current flowing through HC produces force of attraction greater than the spring pull. In view of this, the handle H is held in on position and the entire starting resistance is cut off. The holding magnet or coil HC is also called no volt release or low voltage release. It acts as a protective device. To protect the motor during the power failure and overload conditions, two protecting devices are provided as indicated in the above figure. The electromagnet HC, also called as no volt release, protects from power failure. The electromagnet OR is also called overload release. Function of HC or no-volt release or low-voltage release. 1. In case of power failure, electromagnet Hc gets demagnetized and the spiral spring brings the handle back to its off position. If during the power failure the handle fails to return to off position, the motor might get damaged. In case if the handle Hc is not restored back to off position and also if power comes on, then the current will pass through the handle and go to armature without starting resistance. Hence, the armature winding may get damaged as armature current is high at starting. 2. If the shunt field becomes open-circuited accidentally, Hc gets demagnetized and the starter handle is returned by spring pull to the off position. In case the starter handle is not released, the speed starts increasing with the decaying of the field flux. The small residual flux will result in dangerously high speeds. At the same time, for providing a given load torque, the armature current starts increasing, and in case the fuse or circuit breaker does not disconnect the motor from DC supply mains, the armature may get damaged. 3. With this arrangement, the starting resistance in the armature circuit can either be zero or full. The handle can't be left on any intermediate stud willingly or unwillingly. Note, the field winding holding coil Hc and the starting resistance are in series. Since the starting resistance is much smaller in comparison with the shunt field resistance, its effect on the shunt field current is negligible. Function of OR or overload release. Another protective device OR known as the overload release is provided in series with the armature circuit. This OR is a small electromagnet. In case the armature current exceeds a preset value due to overload, OR becomes more strong and attracts a movable soft iron M pivoted at one end. As the soft iron M is attracted, two terminals A, B of the no-volt release Hc get short-circuited. In this manner, Hc gets demagnetized and the starter arm H is pulled back to the off position by the spiral spring. The motor is thus automatically disconnected from the mains in case of overload. The motor current at which the overload release OR should operate can be adjusted merely by varying the distance between the electromagnet and movable soft iron. If speeds above the normal are to be obtained, the field current must be reduced. At a certain value of reduced field current, therefore increased motor speed, the electromagnetic pull of the holding coil may become less than the spring force. We know the following inverse relationship between flux and speed. At one point where phi is small, If reduces, and as If is in series with Hc magnet, its force is less than spring. In such a case, the starter handle returns to the off position and the motor stops.